Welcome back, guys. This is going to be our last session concerning the first chapter or the fifth chapter according to your book. In this session, we're going to focus on problem solving and fixing some misconceptions. A lot of ideas are held in a wrong way. We're going to discuss these in some details. First, as you can see on the background, I have application 6. I hope that you have tried solving it after finishing the oscilloscope part. In this application, let's solve it first, then we go to the general exercises that we talked about. In this exercise, we are given an oscillogram, a screen of the oscilloscope with a line shown underneath the, between quotations, x-axis or the time axis. The questions are, let me erase these first, okay. Name the type of the voltage you observed on the screen and justify. The value of this voltage is negative y. Determine the value of the voltage UAB. Is the phase of the oscilloscope connected to the point A or point B and Y? Then draw a figure showing the connection, I'll move away, of the oscilloscope to the generator. Okay? First, this UAB can be written as U with index AB. Same thing, okay? Let's start solving. First part was, what is the type of the voltage? Simply, it is a DC voltage or a constant voltage or constant voltage. Now, why is that? Because the displayed line, because the displayed line or graph or oscillogram, displayed line, is horizontal and straight. Now, the main idea here, the main part of the answer is to mention horizontal. Okay? Excuse my handwriting now. The main idea is to say horizontal. Another thing, it's important to say DC voltage. One of the mis-ideas is that some students write direct current voltage. DC stands for direct current, but we don't use it direct current. We just keep it direct or DC voltage. If you want to use the term direct, just drop current and say direct voltage. Okay? In general, DC voltage is the best to be used, or simply constant voltage. So this was concerning part 1. Moving on to part 2. The value of the voltage is negative y. Obviously, 2. The straight line is, or the oscillogram, same thing, is displaced towards the negative y region. Okay? An alternative thing that you can add with no problems is, well, if you can say it's below the, it's fine if you say x-axis, even though, I will put it in quotations, even though it's better to say the time axis. Okay. Now, calculate the voltage. Okay, it's fine now. Calculate the voltage. Calculate the voltage UAB. We use the equation UAB equals Y times SV. And as I always tell you, I prefer that we add units to this equation here so that we won't miss them later. Okay? Dropping the unit or not writing the unit here is not the end of the world. It's not wrong. It's fine. Okay? Equals. Y is minus. Let's go back and read that. It's negative. Now, first division, second division, and over here we have subdivisions. An important thing which might be misunderstood is the number of subdivisions. If I count here, I don't know if you can see it properly, it's on the second subdivision. And each subdivision, remember when we said about divisions and subdivisions, each subdivision is 0.2 division. So if you are on the second subdivision, that is 0.4. So we have 1 and 2, and second subdivision, so it is minus 2.4 divisions multiplied by SV is 5 volts per division, now equals minus 12 volts. Okay? Now before I move on, I need to comment a bit concerning units. Okay? I have written the unit in the equation. I also wrote the units beside the values. Now, it is better that you write the units in the equation and the final answer according to what I think. Nevertheless, if you feel that you are more comfortable by writing the units here, also it's okay. Now one more thing, negative voltage. Voltage is usually positive, but it can be negative according to this exercise here, simply because the displayed value is negative. It is connected in a reverse mode. So just keep that in mind. This voltage is negative because it's red negative. It's not because the generator is giving negative voltage, no. The generator doesn't give negative voltage. Voltage is a positive value. But what we read here is a negative value because apparently we have connected the oscilloscope in a wrong way. Question 4. Is the phase of the oscilloscope connected to the point A or to the point B? A lot of students do this mistake. Is it connected to A or B? How can we tell? Since the value is negative, let's say that it's connected to B. No. The oscilloscope always reads the voltage from the entry to the COM, or from the phase to the COM. So directly what we can say here, for the oscilloscope displays, display is to show, displace is to move. Okay? بس كفوكابولاري لننتبه لهم. So the oscilloscope displays the voltage, according to the given here, the voltage UAB, which is, as we know, which is also UY-COM. The oscilloscope always reads the voltage from the entry to the COM. If we compare these two together, so A is connected to the input, or to the Y input better, to the entry, okay, or channel. Okay, let me erase this, and that's it. So, we know that the oscilloscope always reads the voltage from the entry to the COM. Now here it's displaying the voltage from A to B, therefore A is connected to the entry or adjusted to the entry, or some people might say A is the entry. It's the same thing. Now, last question. Draw a figure showing the connections of the oscilloscope to the generator. So now we need to draw a figure showing the connection of the oscilloscope to the generator, not the way the oscilloscope is connected. Part 5. First, I'm gonna draw a generator. As we conventionally talked, a generator is drawn as positive, negative with larger and smaller sides. We know that the oscilloscope is reading a negative answer, right? Or a negative voltage. So since the oscilloscope displays a negative voltage or a negative reading, which I suggest to use, then the entry should be or is connected to the negative pole of the generator. Okay? Let me fix this. So negative pole. Okay. Okay, of the generator. So all I have to do is go back to the figure here. This is the Y, which we use as the entry, and this is the COM, which is a broom-like shape. That's it. Now, the main idea that I want you to focus on in this part is that the oscilloscope reads all the time, reads U. Why come? It always reads the voltage from the entry to the come, to the negative, or to the come in general. Now, this can lead to two ideas, this one or this one. It might be a positive reading if Y is connected to the positive of generator, and it is negative if Y is connected to the negative of generator. I will just write gen. So the oscilloscope always, regardless of its connection, it's gonna read Y, the voltage, from Y to the come, from the entry or channel or phase to the come, to the ground. Now, if the entry or the phase is connected to the positive of the dry cell or the generator, the reading is gonna be positive, resulting in a line moving upwards. Otherwise, the line is gonna displace, move downwards or below the axis. Now, one more final note. We could have used here another form of a generator by drawing this, G, but don't forget to add plus and minus. One more thing. If you notice, throughout all my discussion, I didn't mention A and B. Yes, that's true, because the reading of the oscilloscope, positive or negative, depends on its connection. Now, if I link this to the previous part, in which the oscilloscope reads the voltage UAB, then I know that if I add here the entry as the same way I've done, okay, then I know that this point here is A and this point here is B. Or if I go to the previous figure, this point here is A and this point here is B. And the oscilloscope is reading UAB, regardless of whether A positive or A is negative. I don't care about that now. The oscilloscope is reading UAB, and at the same time, the oscilloscope is reading a negative voltage. Together are interpreted by this figure. That's it concerning the application. I hope that you didn't have any problems solving it. Now we will move to exercises about the whole chapter. Let's go to exercise 1. Exercise 1, a multiple choice question. Okay? We have 3 parts here. You will notice the other 2 parts in the following page. So let's discuss them together and talk about some details concerning each part. Among the following choices, only one is correct. Choose the correct answer without explanation. هون بننتبه in official exams إذا شي مرة إجا سؤال usually بيقول لك explain. Okay, so usually we explain. Nevertheless, هون قايل لك plainly do not explain. So adding an explanation is optional. ومثل ما على طول بنقول إذا شرحت شوي زيادة ما بيأثر، منا قصة كبيرة. You can add an explanation. وإذا شي مرة كنت ملبك بكتب أو ما بكتب، معلش اشرح شوي ما راح تخسر شي وقت. Okay, here we do not need to explain. The circuit shown in document 1 is a series connection, a parallel connection, a complex connection, or simply an open circuit. Looking at this circuit, you notice that the lamps are connected along one line, right? So if there is a current flowing from positive to negative, it flows without splitting. One of the main ideas is that people might, or a student or an observer might consider the voltmeter here and the multimeter here to be branching. They're not. على طول الفولتميتر والاميتر ما بنعتبرهم branching أو additional. يعني having the voltmeter in parallel مع 6 volts lamp أو المultimeter in parallel هون, this doesn't mean that the connection is mixed. No. Okay? You just focus on the lamps which are connected on one branch, or as we have watched in the video, they are connected from one side, each two together. يعني هذا الconnection is in series. So the answer is series connection. I'll simply just circle that and I'll write a brief explanation. We are not supposed to explain, but I'll add this just for your sake, since all lamps are connected okay, along the same line, okay? No branching or splitting. Okay? So this is just an additional information or an additional idea. Let's move to question 2. In question 2, we have the reading of the voltmeter V, which is connected to the 6-volt lamp, in document 1 is what? Is the voltmeter going to read +6, -6, +12, or -12? We know that voltmeters read the voltage across their terminals, right? If we connect the positive to the positive side of the generator, it reads a positive reading. If we connect it in a wrong way by adding the V or the positive of the entry of the voltmeter to the negative side of the generator, it's going to read a negative value. A better way to see it is the COM, okay? So this voltmeter has its COM connected to this side, closer to the negative of the generator, so it's fine. It's a correct connection, correct as in reading, so it's going to read a positive value. Not only that, we add to this, the voltmeter is connected only across the lamp. So it reads the voltage of that lamp, which is shown to be 6 volts. 6 volts connected properly, then it's going to read +6. Okay? 2, writing a quick explanation. V reads the 6-volt voltage, okay, with the COM closer to negative of battery, of dry cell, then it displays simply the +6 volts. Okay? So always think about 2 ideas. What this device measures, what is this device measuring? Second, ask yourselves, is the COM connected properly or is it connected in the wrong way? If it's in the wrong way, then it reads a negative value. If it's connected properly, it needs a positive value. In all cases, connecting it across a device simply displays the voltage of that device. Third part, the reading of the multimeter in this document is +4, -6, -2, -4. Now here we have a multimeter, not a voltmeter. But we know that a multimeter can be used as a voltmeter. If you check here, we are using the V and the COM. So yes, this multimeter is functioning as a voltmeter. Now, the COM is connected closer to the positive. So it's going to read negative. So I will choose either this or that, or this as well. Second, it is connected across which points? This until this point. So it was going to read the voltage of this lamp plus the other lamp, which is 4 + 2, 6. So let me dissect my answer. Part 3, multimeter reads, or multimeter, let me erase this. The multimeter measures the voltage between brackets 2 + 4, which is 6 volts. Now, COM is connected to the positive of the generator, then what? Then it reads, or it simply displays -6 volts. And my answer is B. Okay? So I've chosen the values here, or my choices, I've displayed them here. Explanation, which is not required. I just added this explanation or these explanations for your sake in case you do not agree with my choice here. That's all concerning the first exercise. If you have any questions, don't hesitate to write that in the comments and I'll try my best to answer them as soon as possible.